it is like this. There's a parent, the daughter formed plus alpha particle. That's what it's about the alpha decay. Then uh, how is that? The parent will take the mass of parent be x here. There's a parent. It is a test. When it emits alpha particle, the daughter nuclei formed will recoil like this, and the alpha particle m alpha will write it will recoil in this direction. It has to recoil. The daughter nucleus formed cannot be a test. The parent will be a test. So when it undergoes alpha decay, the alpha particle will have momentum. Then momentum has to be conserved. So therefore, the daughter nuclei, what happen, will recoil. It's all about the collisions, conservation of momentum. The collision chapter is what we are going to revise now. Nothing to do with nuclear physics, just for namesake. No. Okay, after this, what has to be done? Okay, this much. So he's asking to determine the total kinetic energy in the final state. He has given the de Broglie wavelength. So if you know de Broglie wavelength of the alpha particle, that is what the information what we have. Lambda alpha is equal to 5.76 into 10 to the power of minus 15. Okay, this is a de Broglie wavelength. So from de Broglie wavelength, can we calculate the momentum of alpha particle? P alpha, right? Momentum, okay, or it's a linear momentum. I'll write it here. This should be equal to h by lambda alpha. I don't know how you manage calculation, but very much essential. 10 to the power of minus 34, 5.76 into. So this will be 1 point. I have all calculated. Last year I did all these things, so I'll directly write it. Almost all problems last year I worked out, no? So I have data. Okay, there's a momentum. Now momentum should be conserved. Initially 0 equal to momentum of alpha particle should be equal to momentum of daughter nucleus. So therefore this should also be equal to Py equal to P alpha 1.15 into 10 to the power of minus 19 kg meter per second. No, I got the momentum. Then can we calculate the energy, the total energy, final energy? That should be equal to, if you know momentum, can you calculate the energy? So P alpha square by 2 times mass of alpha plus momentum of daughter plus 2 times mass of daughter. So since P alpha equal to Py, so P alpha I'll take outside. This will become M alpha My by M alpha. M alpha plus My by M alpha plus My square. Substituting all the values. Here what is the problem is momentum we got it, but you look at the masses, they are in AMU. What to do for that AMU? So there one AMU is what, like 931.47 he has given, MV by C square. Because we need mass. How do you? Because here we have something like energy, no? Joule has to come into picture. This AMU you have to convert into the kgs, that one. So 1 AMU is what? 931.47 mega electron volt by C square. Momentum already we have, kg per meter per second. How you do this conversion is very important. So the final energy should be there in terms of joule, then only we can proceed further, no? What is 1 AMU is equal to 1.66 into 10 to power of 1.6 into 10 to power of, now hope you remember from chemistry, 1 AMU we can also write it as 1.66 into yeah 10 to power of minus 27 kg. Okay, then I think now we can convert very easily. Substitute that and solve. So I have answer. The final energy is 10 to power of very difficult, it's not that easy, but you should be very fast in all these calculations, there's no other way. Now we got this energy in joule. Now we have to convert this into mega electron volt, because we have the masses in terms of, because it's asking the mass of parent. Okay, energy is what we have got it. Obtain the mass of parent nucleus is asking mx. Now we'll do one thing. I'll go back to this one. What is energy released? Energy released should be equal to mass of parent minus mass of daughter plus mass of alpha particle into c square. And this Q is nothing but this one. Now after this, what you can do is asking mass of parent. Okay, shall we convert this Q in joule into mega electron volt, or from there AMU we can bring it. Or delta M, this Q is nothing but Q, will get it, convert into calculate the mass defect. If you can calculate the mass defect of this one from here, so what is the, I'll do one thing, I'll bring it here, and now after getting this E, this is equal to Q. Okay, this one, we'll write it here, where this is E, we have to convert this Q, where this Q is nothing but EF, from the mass defect Q equal to delta MC square. So that delta M is what I should bring. Now what we have is mass of the daughter and alpha particle are there in AMU. This delta M I had to convert into AMU. So 1 AMU is what? 931.4. Like this we can adjust here. First Q in mega electron volt is needed. I'll do conversion. Simply telling will not help you. This is Q equal to, in terms of mega electron volt is needed, EF mega electron volt. Here mega electron volt I'll bring it. Then this will become 1.6 into 10 to power of minus 19 into 10 to power of 6. This will be 10 to power of minus 12, 1.6 into 10 to power of minus 30. I think we have to solve this. Anybody? Q. Uh, 100 by 16. 100 by 16. 50 by 8. Okay, yeah, fine. 6.25. Okay. 6.25 mega electron. Now I got the Q. Convert this into, okay, Q is what we have, this one, this mega electron volt is there. Convert this into AMUs, so that we'll get the mass of the parent nuclei in terms of AMU. In AMU is asking, intentional is asking. How to convert this into AMU? Divided by, so this, I will, okay then, yeah. So based on this, Q will be 6.25 by 931.47. This should be equal to mx my plus m alpha. Okay, solve this. We know mi, so this everything will be there in AMU now. So then the mass of the parent will come. So you check it later on. I had to cover plenty of approximator. I'm not sure. I'll write only up to mass of parent. So do learn, if you have energy in joule, how to convert into megaelectron volt, and if you have energy, how to bring the energy in terms of mass AMU, or if AMU is there, how to convert that into energy is what all needed. You need a practice, that's all, nothing is there. 1-2 problems if you do it, no.